Have a quick look at equations. And of course, the basic idea of an equation is to make whichever pronumeral it is that you're trying to find the subject of the formula or the equation. So I guess the first type, well, maybe not even the first type. The first type you probably did back in primary school. And you didn't use pronumerals, you might have had box plus 3 is equal to 6 and what goes in the box, or triangle, or things like that. But really, you were doing a crude form of algebra when you think about it. It's just that the box represented the pronumeral. Same idea. Most people, I think, look at this sort of question and say, well, how do we solve it? Well, we say, well, whatever we do to one side of the equation, we do to the other, so I'm going to subtract. Well, I sort of do it that way, but it's a different way of thinking about it. I think about it as shifting terms around. So I want to get the x by itself. So that 3, I want to shift to the other side. But I know that when I shift something through an equation sign, I change the sign of it. So it becomes 6 minus 3. So effectively, it's the same as saying, oh, I'm going to subtract 3 from both sides. But it's just a different way of thinking about it. And so, of course, we get x equals 3. And so when we have 5z equals 45, if we want to undo the multiplication, we want to do the inverse operation, which is division. But we don't do it as division, of course, we do it as a fraction, because when you think about it, that's all division is. I don't know whether you've thought about this before, but that's why the division symbol looks like it does. Because the division symbol is a vinculum with something on top and something on bottom. We just put 2 dots there to represent the fraction. Hence the division symbol. I don't know whether you've thought about that before, but that's where it comes from. But the advantage of writing it as a fraction is that if it doesn't simplify down, well, and this one does, of course, you've got your answer straight away. You don't have to do anything else. Okay. Parentheses. Well, we have a couple of choices here. We could expand out first, then solve it, or I could divide by the 4 and then solve it. It's really just a choice. What did I do? I've expanded out. Move the 20 to the other side, divide by the 4, bingo, there's our answer. Then, of course, we got a little bit more sophisticated and we said, hang on, what happens if we've got pronumerals on both sides? Ooh, gets tricky. Well, that's all right. I just want to move everything with a pronumeral to one side and everything that doesn't to the other. So I'm going to move the z over to the left and I'm going to move the 2 over to the right. 2z equals negative 11. And here's what I was talking about with the fraction. By writing it as a fraction, I don't go any further. Oh, pronumerals in the bottom of the fraction. Okay, again, we can do 2 things here. I could add those algebraic fractions together first. I'm not going to do that. I think I would have just decided to, let's multiply everything by the common denominator, which is, if it's not there, put it down. So in this case, I'm going to multiply everything by 7y, and we end up with that. 21y is 19, y is 19 on 21. This classic sort of question. If you have fraction equaling fraction, cross multiply, like so. So multiply along the crosses, 3x plus 9 is 10x minus 30. I mean, it's a very specific case, fraction equals fraction, but it saves mucking about trying to work out, common denominators, what cancels and so on. Move things around, 7x is 39, 39 on 7. All right. There's the basics of equations.